All right, welcome back to this explainer. Today we're diving into a really fascinating translation exercise straight from Module 4 of the Legal Engineering syllabus. We're going to explore how we can take the traditional, highly logical legal mind and literally translate that into dynamic computer science grammar. Really, it's all about shifting from static paper drafting into an active execution environment. We'll be looking at how mastering concepts like variable storage and typing domains can absolutely revolutionize how we view modern legal deliverables.
Okay, let's dive into this with a clear roadmap of what we're covering. First, we'll look at static sheets versus active scripts. Second, typing domains and validation. Third, assignment versus equality. Fourth, reading right to left. And finally, number 5, the dynamic legal mindset. Let's get right into it.
Section 1, Static Sheets versus Active Scripts, also known as the active canvas. So, our very first step today involves completely shattering the illusion of static text. As legal professionals, we're used to information just kind of resting passively on a page, right? But I want you to ask yourself, how does a single data entry behave differently on paper versus in code? I mean, really think about that for a second. When a word is typed onto a printed contract, it just sits there. It relies entirely on a human reader to interpret it, to enforce it. It's essentially dead material until human action comes along and revives it.
But there is a really sharp contrast when we move over to code. A static spreadsheet is just a passive representation of data, much like paper. But an active, running script, that is dynamic. It is actively manipulating and tracking variable storage in what we call a runtime. You know, in law, a performance is the fulfillment of an obligation. Well, in software, that performance is the runtime. You design the system, you hit play, and the machinery physically does the work you instructed it to do. It's like building an engine instead of just drawing a picture of one.
Section 2. Typing domains and validation, the structural rules.
Now, once we've stepped into this active script environment, we really need to understand that the system enforces very strict structural rules. We call these typing domains. This refers to the strict validation of data by the code to prevent errors at runtime. Because this environment processes data autonomously, it can't rely on human intuition to figure things out. It decouples the underlying logic from the actual data being processed. If the active machinery tries to run a math equation on a word, the whole system just crashes. It needs to know exactly what material it's working with.
And this brilliantly illustrates exactly what specific data is being strictly validated to prevent those crashes. These are the 3 core data primitives, basically data primitives 101. You have strings, which is just a fancy word for text. You have numbers, which are obviously used for math. And you have booleans, which are simple binary true or false statements. By mapping these out, we establish the base material for our instructions. A string operates very differently than a number, and a boolean acts as a kind of legal true or false gate for your conditional clauses.
Look, I know this might feel like entirely foreign jargon right now. It can seem pretty abstract, but here's the secret. Lawyers already excel in formal logic. They just often lack familiarity with this specific, strict computational grammar. Your existing skill set is actually your biggest advantage here. The legal mind is highly trained in rigorous thinking. You already map out super complex conditional clauses in your head all the time. All we are doing here is learning a new syntax to express the logic you have already mastered.
Section 3, Assignment versus Equality, the grammatical hurdle.
Okay, this brings us down to the micro level and what the syllabus calls the ultimate linguistic trap for lawyers, the difference between assigning a value and checking for equality. In natural language, and especially in traditional legal drafting, we use the word equals interchangeably. We might say rent equals $500, meaning it is $500, but we might also ask, does the rent equal $500? In natural language, context clues save us from getting confused, but in an active runtime environment, lacking this grammatical distinction will cause massive failures. The computer has no intuition.
So the crucial point is really all about the symbols themselves. A single equal sign means you are assigning or associating a value to a variable. You are issuing a direct instruction. You're telling the computer, hey, take this variable and put this value inside of it. Conversely, a double equal sign means you are checking or evaluating if 2 things are legally or mathematically equal. You aren't instructing the computer to do anything, you are asking it a true or false question. Confusing the two is a big deal. It means you might accidentally overwrite a critical variable when you merely intended to ask a question about it.
Section 4. Reading right to left, adjusting your eyes. To take that abstract concept of variable assignment and make it totally practical, we actually have to physically adjust our eyes. Reading code requires breaking standard English prose reading habits. When you read a standard contract, your eyes naturally track from left to right, line by line, right? But writing and reading computational syntax, especially with that single equal sign we just talked about, requires breaking that deeply ingrained directional habit. The source material compares this to adjusting to reading Japanese text, which is traditionally read top to bottom, right to left. Code requires a very similar mental adjustment.
Let's move to and see how this builds into a very simple mechanical procedure that you can memorize right now. Step 1. Look at the data or the mathematical expression on the right side of the equal sign first and evaluate what that data is. Step 2. Take that evaluated data and assign it to the variable sitting on the left side. It's like you process the right side and then pack it into the container on the left. By mechanically training your eyes to jump to the right side first, you instantly decode one of the absolute most foundational patterns in programming.
Section 5. The Dynamic Legal Mindset. Rethinking Legal Logic.
So, we've covered active canvases, typing domains, and the grammar of assignment. But why does this all matter? The ultimate goal of Module 4 is shifting the legal mindset from a static view of legal documents to a dynamic calculus or performance runtime perspective. These micro-lessons are just the building blocks of a massive paradigm shift. Think about it. In the future, legal deliverables won't just be stacks of paper. They are evolving into modular software dependencies. By learning this computational grammar, you are literally future-proofing your ability to architect legal agreements that actively enforce themselves. Which leaves us with a final, provocative question. If modern legal deliverables are indeed evolving into software, how will you rewrite your mindset from static drafting to active state tracking? The transition from paper to code is already happening, and it's minimizing transaction costs across society. And like we said, your logic skills are perfectly primed for this. All that's left is mastering the active canvas. I really hope this sparked your curiosity to dive even deeper into legal engineering. Keep asking those big questions, and thank you so much for learning with me today.